Hi, welcome to my YouTube channel. Today we shall be looking at Dalton's law of partial pressure, and the law states that the sum total of partial pressure of all gases is equal to our total pressure. Now the sum total of partial pressure of all gases is equal to our total pressure. You know, in gaseous state of matter, we say that the molecules there are freely apart, and they have the ability to move from one place to another. That is, the kinetic energy in that state of matter is very high. So let's assume that we have a container like this that is made up of three gases, that is nitrogen, oxygen, and chlorine. So let's assume that this is nitrogen gas, this is chlorine gas, and this is oxygen gas. You know, these molecules or gases here will keep moving from one place to another, changing direction and making collision with themselves and the wall of the container. So the pressure exerted by each of these gases in the container is known, or is called its partial pressure. It's called its partial pressure. So now the sum total of this pressure of gases in the container is equal to our P total. Is equal to our P total. So it's important we note the following formulas that can be used to tackle so many problems under this law, because most of the times there are questions under here that has to do with the general gas equation. So if you go ahead using the general gas law or equation, you'll get it wrong. So the number one question I want us to note, formula I want us to note here is this formula 1, which says that P total, that is our atmospheric pressure, is equal to partial pressure of nitrogen, oxygen, chlorine, and etc., depending on the number of gases you have. Very important, we note that. Now, you can be asked to calculate the partial pressure of any of these gas. You can be asked to calculate the partial pressure of any of these gas. So if you are asked to calculate the partial pressure of any of these gas, what do you do? For example, let's make the partial pressure of oxygen the subject of the formula, or let's calculate the partial pressure of oxygen. So for example, that is being asked, then our formula will be like this. That is, the partial pressure of oxygen is equal to numbers of moles of oxygen. Now, since we all know that the symbol N is equal to numbers of moles or amount, so N is equal to numbers of moles or amount. So I will be using N to denote or to represent numbers of moles. So if I want to calculate the partial pressure of nitrogen gas, of oxygen, now it will then be numbers of moles of oxygen all over numbers of moles of nitrogen gas plus numbers of moles of oxygen gas plus numbers of moles of chlorine gas times our P total. So if you are asked to calculate the partial pressure of oxygen, it will be numbers of moles of oxygen gas plus numbers of moles of nitrogen gas plus numbers of moles of oxygen gas plus numbers of moles of chlorine gas times our P total. Times our P total. So this is the formula used to what? To calculate partial pressure of any of the gas. Now it depends on the numbers of gases that we are given. It depends on the numbers of gases we are given, but we should know that partial pressure is equal to numbers of mole of that gas all over sum totals of mole of all gases, then times our P total. So this is our equation number 2. This is equation what? Number 2. Then the number 3 equation here that I want us to note, to take note of, is this ones that said so the number 3 formula here I want us to note is the one that says what? Amount or numbers of moles is equals to what? Mass over what? Molar mass. Amount or numbers of moles is equals to what? Mass over what? Molar mass. So if the mass of the gas is given, you divide it by the molar mass of that gas to get your amount, so that you can use it either to calculate the partial pressure of the gas. Very important. So the number 4 formula I want us to note here is this. So this one said P1V1 is equals to what? T1. P1V1 over T1 is equals to P2V2 over T2. This is general gas what? Equation. This is general gas equation. P1 is our initial pressure, V1 initial volume, T1 initial temperature, P2 final pressure, V2 final volume, T2 final what? Temperature. This is our equation number 4. This is what? Equation what? 4. We need to know it. Then the last here but not the least says that P total so now this one says that P total is equal to what? The pressure of dry gas plus water vapor pressure. P total is equal to what? The pressure of dry gas plus what? Water vapor pressure. And if you make the pressure of dry gas the subject of the formula, you have what? P total minus what? Water vapor pressure. P total minus what? Water vapor pressure. So these are the possible equation we can use to solve any or to tackle any JAM question or WAEC or NECO question that has to do with Dalton's law of partial pressure. That has to do with what? Dalton's law of partial pressure. So I can name this video as 1. Dalton's law of partial pressure. What? Dalton's law of partial pressure 1. So subscribe, as I said, so that you can follow us as we continue to solve past JAM and WAEC questions under this topic and the possible questions that JAM and WAEC can ask you.